Hello and welcome to the fifth episode of the Bring It Out podcast. And today I'm very excited to introduce Salma Ahmed, a PhD student at UC Berkeley in Earth and Planetary Science. So it's great to have you with us today, Salma, and please feel free to introduce yourself.
Hi, thank you so much, Juman, for inviting me. So my name is Selma. I am a third year PhD student at UC Berkeley. My background has primarily been in chemistry for my bachelor's and master's, but now I'm sort of applying it to Earth and planetary science.
Thank you for
Thank you.
joining.
Thank
And
you.
for those of you who are new to the podcast, I'm Jaman, a student based in North Carolina. So let's go ahead and get started. So, Selma, I'm really interested in starting at the beginning of your journey. So, could you tell me of any moments or experiences in your early childhood that might have shaped your love for science in general?
Yeah, that's a funny question because I would say you know, prior to high school, I can't say there was really one pivoting experience. I would actually say that my passion has been music for a long time, but over time, it wasn't until I started taking chemistry in high school that I realized that I really enjoyed it. And, like looking back, there were maybe like certain documentaries that would be interesting from time to time, but it wasn't something that I was like it wasn't necessarily like my calling from the beginning, but rather like over time as I had positive experiences in chemistry that I realized that this was something I was very interested in.
And in your time at UC Berkeley, did you have any mentors that helped you grow both personally and professionally as you study for your PhD?
Yeah. So I would say that, especially with the department that I'm in, we are a rather small department compared to others. So I would say the grad students have definitely been wonderful mentors. We have like a sort of mentor mentee groups for students that have passed their qualifying exam versus those that haven't yet. Um, Postdocs in the lab have also been very helpful. My advisor, as well as undergrads too, actually, especially when I first came, just because like the undergrads I've met have already been in the in Berkeley for a few years, so in a way, like they had more experience with the institution than me. So, I actually learned from the undergrads as well. So I would say it's like everyone is kind of helping each other out. It's not necessarily just one, mentor and then a bunch of mentees. Sometimes it can be that way, but I would say sometimes it's like I find myself helping others as well. So it's a little bit more of like a community based sort of help.
Thank you for sharing that. I mean, community is such an important part in, not just education, but, in any endeavor or job that we could go on to do. Talk to me about your bachelor's and master's in chemistry. Why did you decide to focus on chemistry specifically, and why are you so passionate about it?
Yeah. So I guess going back to my experience in high school, um, I think it was just interesting to write out chemical formulas and how, if you have these two reactants, you're going to get these two products. Um, and I think from there, I just sort of took more chemistry classes. So my junior year, I took AP chemistry. And I was very lucky that in my senior year, there was one teacher that offered organic chemistry every other year. So thankfully, it lined up for my senior year. From then I realized like, okay, this is something that I want to pursue. Now for the bachelor's, it's labeled as just chemistry, but of course there's like multiple disciplines in chemistry. So I came in thinking I would continue like organic. Like I thought, oh, I would do like pharmaceuticals or something. And part of the degree program, oh, I should also mention this was at San Francisco State. So still in the Bay, but a much smaller school than Berkeley. So for the bachelor's, um, you have to take a year of chemistry and sorry, a year of organic chemistry. And the first semester was a lot of what I learned in the high school course, but of course, like, at a higher level. And then when I took the second semester, I realized it really became a lot more memorization, which is not my strongest suit. So it wasn't a bad experience, but it did make me realize that, okay, I want to stick with chemistry, but maybe that particular avenue of chemistry is not for me. So I, continued to take courses, and one course that I really enjoyed was something called quantitative analysis. And it's like a fancy way of saying like number one, we have to apply, statistics to the data we collect. And also, we were given the chance to use like real spectrometers to collect data. So it wasn't just like, okay, you make something and then, you give it to the advisor and they like analyze it. But we were actually given like X-ray diffraction. We were given IR spectrometers, which like they all classify materials in different cool ways. So it was really nice to do that. So I thought, okay, maybe I'll do something like this where I'm like, and I know it sounds super vague, but it's like analyzing samples in that more technical sense. Um, and for the bachelor's and master's, I stayed in the same institution. So in the end of my bachelor's, I took this physical chemistry course that the professor was really great. And the thing about physical chemistry is that it's very much like quantum chemistry, so it gets really heavy in the math, and it gets very like trippy in a way, for lack of a better term. But the instructor that I had, she was really great in making it super interesting without getting super deep into the math and like bombard us with all of the calculus and such. So I decided this was like I think the spring of my junior year. So I think that summer, I asked her if I could join her lab because a lot of professors in universities, they also have, I mean, depending on the type of institution, but usually for professors, they have like a lab to do research. So I decided to join her lab, and it was a computational lab. And what that means is that we do not work with chemicals at all. It's all simulated atoms and such. And mind you, I came in with no Python or any type of coding experience, so she was super supportive in giving me the little basics I need. So literally, I took this like asynchronous online high school Python module for this just to like learn the basic syntax, and then and then from then on, she kind of gave me, little tasks to like analyze data. How do you, get a text file and plot that in Python and things like that. So, that was really going into like, that was like the summer of my junior year, going into my senior year. And then my master's, I stuck with the same advisor to study superionic materials in order to improve batteries. Yeah.
Thank you for sharing that. And moving on to your PhD studies, why did you specifically decide to move from chemistry to this new kind of science, which is Earth and Planetary?
Yeah, that's a very funny story, actually. So when I was doing my master's, I was funded by this external grant that required you to apply for PhDs. And the idea is like you don't have to accept it, but you have to at least apply. And the idea is that um, to have more, especially marginalized students, have the opportunity to go into PhDs. So like part of it meant that yes, I would receive this grant, but I would also have to take this 1 unit colloquium in order to, work on personal statements and all the things I need when I'm applying for a PhD. And that was like, especially, in this day and age, it was very much a blessing. So, but I didn't want a PhD. So I thought, okay, I probably won't get this much support again. So let me still utilize it, but I will be very picky on the place that I go. So when I was looking into chemistry programs and sort of like the research that the professors do, none of the research really interested me. And that's not to, belittle or demean like the the other, chemistry professors, but it's like in any of those institutions, a lot of them are working with like proteins in a more like biochemistry context, or like I guess in the complete opposite end is like intense physics where it's really like just math and such for this modeling electrons and all. So there was like it was kind of like these two sort of extremes of life science versus physical science that there wasn't anything in particular that really there was no like project that I or there was no type of research that I thought okay this is something I could really stick to for let's say 5 years or something. So I decided to look into, at the time, astronomy programs, just because I found that space science was always very fascinating. I think I took like an intro to astronomy course a little bit before I was applying just to see like, okay, is this something I want to do? And now I know astronomy and planetary science are very different. There's some overlap, but they're actually very different because astronomy is a lot more on the stars, whereas the planetary science is on the planets. So I my criteria was like, okay, I want to do space science of some kind, so apply the simulations that I do for chemistry for the sake of batteries and apply that to space. I also want to stay in California, ideally stay in the Bay, but like at least in California. And I think those were like the main two criteria. So I think the professors that were running the colloquium were saying, oh, you should apply to at least like 10 schools. I applied to like six, but I only cared about two. So it was UC Berkeley and UC Davis. So UC Berkeley, the professor that I'm working with now, he applies the same type of simulations that I did called molecular dynamic simulations. So like movies of atoms moving around and certain pressures and temperatures to see like how would they behave? Would it be a solid? Would it be a liquid? That kind of stuff. But now for these like extreme conditions where they're inside planets, right? So that means like extremely high pressures, you know, everything becomes a metal at high pressure, which was something that I learned coming here. So like oxygen, which we think of just like as a gaseous molecule and stuff, that becomes a metal at high pressure just because you're squeezing all the atoms next to each other. So that was the Berkeley route. And then for UC Davis, oh, I should also say when I looked into the when I looked into the professor here at Berkeley, I found him under the astronomy department. But when I talked to him, he said it's best you apply to Earth and planetary science because they don't require you to have an Earth and planetary science undergrad degree. And then for Davis, that was actually under a chemistry department. And the professor, I think this was like the only place I saw, at least in California, that a professor had astrochemistry as like their description. So it was like exactly like what I was looking for. Like chemistry in space. Okay, he has a fine name. It's perfect. Um, and I actually got offers from both, which was really nice. And for a while, I thought I was going to go to Davis just because they got back to me first, but ultimately I chose Berkeley because the research itself is more aligned with my skill set, I would say, and also because I get to stay in the Bay.
Well, thank you for sharing that. And as you went through this whole process of applying to Berkeley and Davis, what would you say are some college application tips that you could provide to current high school students who might be, in the application process and they're about to submit and they just need some advice?
Yeah, so it's funny because I applied to Berkeley and Davis as an undergrad and I got rejected to both. And I think I mean, there's a number of reasons. Number one, I'm applying for a grad program, so they look for different things. They definitely want you to have more research experience and like you in a way you have like more experience that you could like testify going into these programs. I would say the flaws of my undergrad application versus my grad one, besides like I guess experience, is focus. So I'm not saying that like, you need to know what you want to do, but I think they want to see that you are passionate about something. I think my, I think my application for Berkeley at the time was like very generic. I don't even remember exactly what I said, but it was very generic of like, oh, like the, my parents, you know, like I guess my parents came to this country at a certain time and now I want to make them proud. And I'm not saying that's like a bad thing to say, but there's a way to say it. And I
Yeah.
think for me, I just said it for the sake of saying it. Whereas for others, like there's actually more into that. Like, okay, my parents are passionate about this thing, but maybe they couldn't pursue it, but now like I want to do this to help them or to help a certain community or something. Like there's like a clear purpose on doing what you want to do and what you want to explore. And it doesn't mean you're going to be held accountable for it either. It's not like they're going to check to see, okay, you said you wanted to do this thing, where's the results? Like you don't have to do that. But I think like what they want to see is like, okay, you're someone who is passionate about something. Um, that is like I think what they care about the most. And I think sort of a misconception that I hear people say is like you have to show a level of struggle. Like you had to be underprivileged in some way in order to get opportunities, and you have to like really highlight that. And it's like I think the way these applications work is like they if you did have some misfortune or something, okay, how did you overcome a certain barrier, right? Like that's still important, but I think it's like it's not inherent that like you have to have that in order to be seen as like a hard worker. Like there are ways to go around that, and one of them is saying what you're passionate about. So maybe like you didn't have a particularly like unconventional youth, but at the same time, it's like this is what I really cared about because I like this since whenever. Or talk about how your interests have changed. Like okay, yes, I did like this, but in reality, I found that I really like this. So I would say like definitely overall showing passion, showing focus, showing like something that like you really have like a stance in, as opposed to just like, oh, this is generally my life story and I don't know what I want to do. And it's okay if you don't know what you want to do, but I think there's a way you could phrase that so it's a little bit more focused and like goal oriented, if that makes sense.
And as a PhD student, what would you say are your like research interests?
Yeah, so I guess the group that I'm in, we model planet interiors and like to in order to figure out like what does the interior of the planets even in our solar system look like, because for the gas giants we don't fully know that with confidence. Like we have ideas on like okay, there's certain layers, but maybe how those layers are stratified might not be as like well known as we would know for like the earth, for example. So I would say my research interests are definitely um, along those lines, like seeing how materials behave very differently at higher pressures as opposed to ambient conditions like on the earth or in our day to day. Um, I would say like maybe something that I don't fully do myself, but I always found very interesting is um, like star interiors, which is like something that again we don't really look into, but it was also something that was I kind of hear from seminars that I find pretty cool, and just like life cycles of stars too. Like, so it's such a big like grand thing that I always find fascinating. Which again I don't do, but like one great thing about grad school is that like there's always interesting seminars of other people visiting and such, talking about their research. So even if you're not an expert, um, you end up learning, a cool thing, and you end up meeting new colleagues that maybe, like in the future, can be collaborators for papers.
Thank you for sharing that. What would you say are some like key lessons that you've drawn from your experiences as a graduate student researcher?
Yeah, that's well, I guess maybe one of them, I guess if I had to think of my master's, because that was like really my, like the senior year of undergrad going to my master's, that was like really my main first experience with research. It is very different from homework because there is no solution you refer to. And I think it's as a result, it's a different type of problem solving because again, with homework, it's like there's a certain deadline and to get this answer, which is already known, and you would kind of move on to the next thing. Research, it could take a long time. It could take years. Maybe not on the single question, but like sometimes maybe for the bigger question, it could take several years. But that doesn't mean that like, you as a researcher, um, don't know what you're doing or anything. It's just more so of like, okay, this is a very big thing, and there's so many different components to this bigger question that it takes a whole like scientific community to figure out. And then adding on to that, one thing I learned is that like when people, let's say, present something about their research, they're not presenting the big answer. They are presenting one finding for a smaller question. So it's like, okay, I don't know exactly, let's say, what's the composition of this planet, but I just wanted to know, okay, I think it's probably is going to have this element. So, or sorry, in this compound. So, what happens when this compound is in these conditions? What is the outcome for that? So someone would have a whole talk just on that small question. And because I remember there was one time, like an undergrad was I forgot what we were talking about, but this was brought up, and basically she was asking like, okay, when am I supposed to like have enough data to present and such? And I'm like, really, if you have just a few figures, that's how you present. It's not like, oh yeah, only do it at the very end when you somehow like solve the big scientific question that like 10 other labs are already looking into. So in a way, I appreciate that. I think because it's like it's not this one hard deadline that is stresses you out, but rather like this is a gradual process that okay, in I might have this answer, but in reality this answer might lead to more questions, or in reality this particular mechanism is not correct or something, so I'm going to try this different mechanism that might lead to the desired outcome we want, things like that. So I like that it's in the kind of like nature itself, where it's like not super linear and everything. It's kind of everything sort of ties together in different ways. So it's definitely, yeah, definitely be patient with yourself when it comes to research. I'd say that's a big thing I would say.
Do you see yourself in the next 5 years, as you finish your PhD? Is there like a specific career path that you want to go on to, maybe like a professor or something like academics or something like that?
Yes, I actually would want to be a professor.
Okay.
Yeah, yeah. I think like I was a TA for my master's a few years and I really enjoyed it. Going into Berkeley, I did focus on research a bit more, but last semester I was also a TA. And I think that reminded me of how much I do enjoy teaching. So I would definitely want to go the professor route. I know with the PhD, there's like a lot of postdoc positions where they sometimes also work in an academic institution, but sometimes they might work um, in industry or in like a federal institution. So oftentimes when if you want to be a professor, you do have to have some of that like postdoc research where, okay, you're still working with a PI, but you have a lot more independence on your own research and it's not tied to a degree. So I would say like I would probably need to do that first, but ultimately I do want to be a professor. Where? I don't know yet. Because now I'm learning that different institutions sort of have different um, rules when it comes to teaching. So some institutions they really want you to just do research and then you teach one or two classes. Others they really want you to teach and then you do a little bit of research on the side. So I'm trying to find like that balance to navigate sort of like where I would want to be as a professor.
And what advice would you give the next generation who might be interested in pursuing a PhD in, some science-related field, but they don't know really where to start? Like, are there any actionable steps that somebody could take after watching today's episode?
Yeah. So I would say that for PhD programs, they usually require research experience. So definitely, like there are plenty of internships available in the undergrad level. There's like all kinds of mailing lists for that, so you'll definitely like find them. Uh, and you don't have to start like your freshman year. There's some students that I've met like here in Berkeley, for example, like they really started like, right away, which is good. But I did not. I didn't start until like my the summer of my junior year. So I really had like my senior year. But at the same time, uh, some students they go from undergrad straight to a PhD, whereas for me, I went through the master's route. So I would say, in order to find like besides internships, if you want to do research, I would also recommend like as you're taking classes, talk to the professors. of the classes you're taking. That's literally what I did. Because like this, the number one, the professor will see like how well you do in the subject they're teaching, because chances are it's related to what they do, and it's a way for you to like have a more long-term mentor, if that makes sense. Because I think for internships, like especially if it's in the summer, it's usually only a few months, right? So whereas for the undergrad research with the professor, that could last until you graduate. So, for if you start, yeah, so if you start in your senior year, then you have like a whole year with them. So that's really good. And then that could be a great like letter of rec for grad school too.
Yeah.
Um, and one final thing, which I know financially isn't the most feasible, don't be afraid to do the master's first. I think like depending on the undergrad institution you go to, like if I were to compare to SF State versus Berkeley, UC Berkeley, UC Berkeley has a much stronger emphasis on research. So as a result, there's like a lot of students that it's almost second nature to just go straight to a PhD, which is fine. Like if you that's something you want to do, you should absolutely do it. But I think that it's important to note that that's not the only option, right? And not everyone likes grad school. Just because like the grad school, it's a lot of um, it's I don't know how to explain it. It's like if I guess some people prefer to have industry job just because it's like you clock in, you clock out, I do this thing, and then I go home. Kind of a little bit more on the busy work side. You're still like it's still honest work, but like maybe it's a little less of asking bigger questions. And some people want that. And then others they would want to continue to do research. But undergrad research is very different from grad research. So I think having the master's would mean that okay, you're doing this for 2 years and you get like a diploma out of it. So like you um, have like proof to show like okay, I could ask big scientific questions, but I could just go straight into industry or um, something beyond academia um, with this master's degree. As opposed to going into a PhD and then you're really there for like 5 years and it's, maybe you find it's not for you. Some PhD programs you can master out. So like, oh, after 2 years, you could just take the master's and go. But not all of them do that. So I would say like the graduate school is a great thing to have. And I love it. But I think like definitely it's important to always have that conversation with yourself on what you want to do as opposed to what everyone else is doing. So I think that the master's is definitely underrated. But when I mentioned financially feasible, PhD programs, they pay you. So you don't pay tuition, they pay you, you get a salary less than what you would get from industry. So that is a bit, sad. But at the same time, you get a PhD out of it, and that means you can get much, we have a broader range of careers to choose from. The master's usually is not paid. I was very lucky that I was in a program that had external grants that I applied for, but usually the master's is not paid. So that sometimes is also what steers people away because like I'd rather just have the PhD and I have that guaranteed like funding while I'm doing grad school.
Thank you for sharing that. And what are some of the most difficult parts of, your work and being a PhD student?
Yeah, I would say like confidence plays a bigger role than anticipated. So when I like I'm explaining things, I find that I do say I think a lot, which has its place, right? I don't think it's like that bad. But sometimes, especially when you're in a place like Berkeley, where like, okay, a lot of these professors and grad students, they're like on the frontier of like the science, right? Like, and they are rubbing elbows with the big names of, people that discovered something. Um, as a result, like you do have to learn to not be afraid to defend yourself. So like if I let's say studied something in my research and I'm describing that okay, this mechanism is what drives this product. Someone else that may be a senior than me might say that's not, I don't think so. But in reality, maybe I spent more time thinking about it than the professor, and in reality, I'm right. But for me, like I tend to like back down. I'm like, okay, I don't want to argue. Maybe it is right. Maybe I misread something. Um, And I think as a result, it can be harder to like properly convey your ideas. And I'm not trying to say that like, oh, this level of research is like a competition and such, but I think like when it comes to science, like, there's there's always room for change. Like maybe the certain theory that we have doesn't hold up anymore in reality. It's actually this other one. But I think we still need to, especially to write good papers and to effectively communicate science, you need to have that level of confidence to really say, like, okay, even if I'm less senior than you, in reality, I actually looked into this more. And these papers show why this mechanism I think is true. And of course, you do this politely, right? But you still want to be like really um, firm with your ideas. And this is really something like I'm navigating right now. So it's not like, I already reached that point. But I'm definitely learning. Another thing is like uh imposter syndrome always comes back. And this is like not to like this, intimidate anyone, but I remember when I finished my master's, I was like, okay, I went into this lab with no coding experience, and then here I am defending my thesis in this computational lab. I'm ready for anything. And then I go to Berkeley, and it's like it's a much bigger school. It's in a different field, and it came back so many times. I think especially because I switched fields. I think if students are willing to do that, they should definitely switch if they are passionate enough about it. Because like I know I'm not the only one, and it's a great thing to do. But like with that, whatever is considered common knowledge may not be common knowledge to you, and sometimes that can like be a punch in the gut. So with that, I think knowing that imposter syndrome always comes back is like helps you handle it better. I think so. In that sense, it'll be and I think it'll help you like sort of overcome it, or at the very least like minimize it when you're doing work and like in your career and stuff. Um, and I guess like this isn't like a difficult thing, but this was something that I think I didn't know coming in is like professors sometimes can be just as introverted as students.
Yeah.
Like, so like, sometimes students would talk to me, like, undergrads saying like, they want to work with this professor, but like they don't know what to say and they're like kind of shy and stuff. And I'm like, you should go and talk to them. Because in reality, like professors, I mean, some are, like students, some are more outgoing than others. Professors is the same thing. Some of them, they just kind of stick to their own little group. So it's easy to think like, oh, maybe they just don't want to talk to me or something. It's like no, they're just shy. So you could totally like reach out to them and such. And some of them are busier than others, so maybe like if they're less responsive, let's say via email, that could be a reason. But technically speaking, like it's not like this introvertedness is something that is fully like you fully grow out of. It's like no, if you kind of were like that before, you might still be that way now. But that shouldn't discourage students from reaching out to professors for research or anything.
Thank you for sharing that. And as we end today's episode, is there anything else that you'd like to add?
I would say that, and it's kind of ironic because I'm in this podcast now, but I would say that success is very nonlinear. And what I mean is like I remember being in these like panels of like students that are like alum, like this was back in SF State, where alum would come in and say like, hey, I used to be undergrad or a grad student here, and now I'm doing my PhD somewhere else. And when they talked about their experience, like it's very inspiring, especially like for the undergrad portion, because it's like, okay, I'm a first generation undergrad student, and like I, it took me longer to graduate. Like it took me like 6 years instead of 4 years or something to graduate. And I'm like, that's really great. That's really, inspiring. And then the next slide would be like, oh, and then I got my PhD in UCLA, and it's like, where's that, where's that transition? And I think like the reason I say it's ironic is it's like right now I'm laying my experiences in a rather linear way. It's like, okay, even if I had this problem, I had the solution. And ultimately that's because of time. Like if I really talked about my life story and I really remembered every detail, then like, we'd be here forever. So I think like in general, don't don't be afraid to try new things, because even if like, because at the moment you don't know if this is going to be like the right path for you or not, but it's important to try so you do know. And I feel like it's not until years later where you realize, okay, this is like, this is the success I've had, in this moment, or in this like timeline and such. Like, okay, maybe before I was interested in doing this, but in reality I'm interested in doing something else, and that in turn, like, uh that taking that initiative to take that new class to see if that's something you're interested in could actually be what leads you to great success. So, um, I will also say definitely be patient with yourself, especially with the work that I do. It's all computer simulation, so like you get the result right away. Whereas others that are experiments, they have to, make sure they have to prepare the sample, and they have to like make sure they have time on the machine to run their experiments. Um, so with that, like I think definitely I know I need to practice patience for myself. So I would definitely say for students, that is something that you would want to do, because like you don't know what your future is going to be. So you definitely take it one step at a time, and then it's not until you look back that you realize like how far you've come the past, few days, months, years.
Thank you so much, Salma. I've really enjoyed this episode with you. I loved hearing all your stories. Thank you so much.
Thank you for having me. It was great to talk about these things too, because it helps me learn. Because I'm definitely
Yeah,
still doing these myself, so it's great
like
to
the benefit is
learn.
mutual.
Yeah, yeah.
Yeah, thank you so much.
Thank you.